Hey, what's up, guys? So let's solve this problem that the maximum splits of positive even integer. This problem is very simple, and I think it's interesting. So I write something which is my own solution. I think it's no, so nobody write code like this. Okay, so yeah, so the idea is that given the final sum, you need to split split into different unique even integer. If you can do this, then you should return false. You should return the possible solution. Otherwise, that you return false. And you need to return the maximum number of the maximum length. For example, 12, you can write 2, 4, 6. And the 7 you cannot, right? So this is very stupid. So you can easily write down if your final sum is cannot divisible by 2, then sure you should return empty immediately. Okay, so this is like a simple results. Okay, and 28 you can write 2, 6. Okay, so 2, 6, 8, 12, and if you see that you can write 2, 4, 6, 16. Okay, so this tell you just tell you the answer, right? So let's say you originally get the number with 2 to n. Okay, and the idea is that you want to find that 2n equals to the possible different possible x, where x is even, and such that the x are all different. So let's say xi and xi are different from xi, xj if j do not the same as I. Okay, so what is the minimum number that it can represent, right? So so the greedy solution, well, the greedy idea is if this is 2, right, the next can must be at least greater or equal to 4, and then at least greater or equal to 6, and then keep going. Okay, so if let's say this is up to 2k, okay, so which is 2 plus 1 plus 3 up to k, okay, which is 2 k plus 1 divided by 2, which is k plus 1. Okay, so you guys just so if your 2n is the form of 2n equals to k plus 1, so basically if you can find such k, then you immediately know the answer must be this, right? Because this is the longest solution that you can ever make. Okay, so for example, the first result is that the first example, let's say n is 6, right? You get 12, and the 12 is 3 times 4, right? So you know that it must be 2, 4, 3. Okay. So if your 2n is the form of k times k plus 1, then this will be the maximum. This will be the solution. This k, this 2, 4, 6 up to 2k will be the solution. Okay, but this is a very special case. Okay, so let me just write down, right? So this is the special case. Special case this 2n, right? Okay, so you can check it, right? So this is k squared plus k minus 2n equals 0. So you can solve k equals minus 1 plus or equal to 1 plus an divided by 2. Okay, and obviously the plus is the only valid solution. So if 1 plus a times n take a square root is an integer, then you immediately return the answer. Answer will be 2, 4, 6, 8 up to 2k. Okay, so this is the first part, right? So you take n to be final sum divided by 2, and you just check that if the square root of 1 plus an is an integer, right? Means that if you take an integer part and take a square root, will be 1 plus an. This means an integer. Then you compute k and to I from range 1 to k plus 1. Okay, so this is the special case part. Okay, so what if your 2n is not a special case of kk plus 1? Okay, for example, the second solution in this problem is n equals to 14, right? So 2n is 28. Okay, so so you can see the answer is 2 plus 4 plus 6 plus 16, right? Okay, the reason is this. If I follow this approach, then I should get 2 plus 4 plus 6, and I want to plus 8, right? But I plus 8, then I get, and this is duplicate, right? So there's no length 5 solution. So this is a length 5 solution. No length 5 solution. So the answer must be must be length 4. Okay, so this tells me that you can do the same thing, right? You can just find a 2 plus 4, 2 plus 4 plus 6, up to 2 plus 4 plus 6, up to 2k, where your n is here. And this is 2 plus 4 plus 6 up to 2k plus 1. Okay, so you can find such k here, where this case actually this. Okay, if your 1 plus a and take a square root is not an integer, then you can find this in this point. And then your answer must be this. Your answer must be 1 to 2 to 3. Your must answer be this up to since 6 up to this point that you cannot find answer, right? Because this number must be one of it. So this guy must be duplicate. So you need to discard this. So you need to discard this. And the final return to 16. Okay. So you need to find the k minus 1 here and use the 2n to minus this previous one. Okay. So what I'm saying is that you still find this k, but you only up to 2a times 1 to k. Okay. You need to, since you don't have your n 2n is not the form of k and k plus 1, so there's no 2k, there's no k length k solution. So you at most have, let's say, k minus 1 solution. So add the final one, which is 2 times n minus k and up k times k minus 1. Okay, the reason is that because 1 plus 2 up to k minus 1 is k minus 1 times k. Okay, so the final results will be, so the final term which you discarded is 2n k and k minus 1. Okay, so this is a pure mathematics solution that you are doing greedy, right? But you only take the square root, so it should be very, very fast. Okay, so you don't, it's very fast solution. You just you don't need like the for loop or something. You just brute force solving it by quadratic equation. See you guys next videos.